Welcome to my final presentations to Climate Wins for their project of data-driven weather technology for a changing futures. In this project, we will come to the objective of this project, the machine learning methods overview, the thought experiments we use in this project, and some summary and recommendation for the Climate Wins company. Firstly, we come to the objective of the project. We want to predict the weather patterns and identify Europe's safest regions from extreme weathers. It comes with three minor objectives. The first one to detect significant deviations in Europe weather from historical norms. The second to analyze if unusual weather patterns in Europe are increasing over time. And the final one, we want to forecast future weather and identify the safest European regions to live. Secondly, we come to the machine learning methods we consider for this project. And in this project, I consider many methods. Some of them are the random forest, the ANNs and RNNs, the CNNs and GNAs. We come to understand the models one by one. Firstly, for the random forest, the models combines multiple decision trees to improve predictive accuracies, and it can apply to feature importance analysis and risk assessments for identify safe reasons. The second one are ANNs and RNNs. ANN stands for Artificial Neural Network and RNN stands for the Recurrent Neural Networks. The ANN detects partial patterns. Meanwhile, the RNNs capture temporal dependencies in sequential data. The model can identify deviations in weather patterns and forecast future conditions. Finally, we consider the CNNs and the GNAs. The CNN stand for Convolution Neural Networks and the GNAs stand for Generative Adversarial Networks. CNNs are primarily used for image classification. Meanwhile, the GNAs are used for generating realistic data such as image, videos, and audio. This model can be used for simulate future weather scenarios to predict potential climate changes. We come to the thought process number one. In this process, I use the artificial neural networks with the accuracy score around 55%. The objective of this process to identify weather patterns outside the regional norms in the Europe and to determine if unusual weather patterns are increasing. The data we use in this process is the historical weather datasets, and the possible use cases can be that from the previous algorithm training, we can predict the rudimentary weather labels, or we can use the continuous variables to better identify patterns and anomalies. The next process number two, we use the combinations of the CNN and the GNA net models. For this process, we aim to identify weather patterns outside the regional norms in Europe based on historical data and images. We have to generate possibilities for future weather conditions over the next 25 or 50 years based on the current trends. Besides the historical weather data sets, we also use another data sets for the weather image. And we have from our previous algorithm trainings, we can identify weather's image label. And from that, we can identify the anomalies based on the weather conditions that we collect from the other sources. Finally, we have by this process, we can train a model on the distributions of weather data in the regions. Finally, we come to the process number three. In this, we use the CNN in the random forest. The objective for using the two network to conduct the risk assessments, conduct the factor assessment in predict weather conditions, and assess regional safety. We also hope by using these models, we can identify weather patterns outside of regional norms in Europe based on the historical data. And mainly in this process, we only use the historical data of the datasets. And as mentioned, uh, we have to find the anomalies and the most dominant factors affecting climate change. And we have to find the safe living areas for the future. Finally, I come to my conclusion that the thought experience number two, use of the CNNs for the spatial patterns recognitions and high accuracy in detecting weather conditions anomalies will provide a robust foundation for predicting future climate change impacts. Combining with random forest categorization power will provide climate winds with comprehensive insight to detect climate anomalies and predict future weather impacts effectively. The GNAs may give various possibilities for the future for better predictions. For the next step, we have to further ourselves in the data collection to refine our models more effectively, and we will have a planning to models implementation further in the future. Besides that, we can apply more suitable models for the time series analysis such as the ANN, the neural perfect, or the LSTM. That's all for my presentation, and if you have any questions, I hope that you can reach out to me and we can have a further discussions. Thank you for listening.